Hi, I'm Matt, and welcome to Tech Tested. Today we're going to try subzero overclocking, but on a budget. So if you're like me, you've checked out channels like Derbauer or Jay's 2 Cents, where they do a lot of subzero overclocking, often with liquid nitrogen or dry ice. And I think to some degree, a lot of us aspire to be able to do that ourselves. Unfortunately, it seems to be prohibitively expensive. If you've ever looked into what it costs to get a proper CPU pot for dry ice or liquid nitrogen overclocking, the cost is upwards of $250 to $300. You also have to acquire the liquid nitrogen and a container to hold it, which I think is called a dwyer. Anyway, the availability of liquid nitrogen is not that common, and the dwyers are also quite expensive. They run like $200 as well. So you're talking close to $500 just for the initial setup. But what if you could get into it for less than $50? Today, we're gonna give that a shot. So what I have here is my overclocking setup that I like to use a lot. It's an Asus Crosshair 5 formula motherboard. I've got a 1000 watt power supply. I've got an AIO liquid cooler. We've got a fan cooling the VRM, just a cheap graphics card that I usually use for this kind of stuff. It's stupid reliable for some reason, and an SSD, and that's what I use for overclocking a lot. Unfortunately, I very frequently hit a thermal wall at like 1.4 or 1.425 volts, somewhere in that range. At that point, I'm reaching the limits of what this CPU is capable of running at, and that is 60 degrees Celsius for the AMD FX series. But if I can get that temperature down, I can start cranking that voltage up. And with this generation of AMD CPUs, 1.55 volts should be relatively safe for these chips on 24/7, but we can go even higher if we're not gonna be using it 24/7. The lack of cooling, even with a 240mm AIO, is really where our bottleneck is. So we're gonna try subzero overclocking. Now, we were able to reach 4.8 gigahertz on this CPU with our AIO, which is actually really good. That might be the best CPU I've ever tested with this platform. And we got a Cinebench score of 742, but I think we can go higher. We're currently running at 1.4 volts with load line calibration set to extremely high. So what we're gonna do is we're gonna tear this down, and I'm gonna show you what I got in order to try to attempt subzero overclocking on a budget. So I'm gonna explain to you a couple things that we did to prepare for this whole setup. And the first thing is something we did to the motherboard. We actually painted some liquid electrical tape over a good portion of the motherboard. And the reason we did that is because once you go subzero overclocking, you get condensation. And so this liquid tape helps prevent condensation from getting on your electrical components and shorting out your motherboard. Now, this might have been a little bit of overkill for dry ice, but one thing my dad always said is overkill is underrated. So we're gonna go with that. Another thing you're gonna need is some acetone. Now, the reason you want acetone for dry ice is because the dry ice actually has to have something to melt into. And so be very careful with this. This is flammable, and don't use it lightly. Definitely take all safety precautions when using it, but this is what you need to use for the dry ice to melt into. There's a couple other things, but actually, before we go any further, I want to talk about my pot. Now, this is where we kind of are getting a little janky. I bought this cup at my local grocery store. Now, there are a couple reasons I bought this one. I wanted it to be copper. It's not actually copper. I think it's aluminum, but it does have a copper finish on it, which looks nice. But more importantly, it has a flat bottom, which is very difficult to find on these kinds of cups, but you definitely want a flat bottom on your cup. And I actually spent quite a few hours sanding this down and lapping it so it would be as flat as possible. It's not perfect, but it's a lot better than it was. So this is going to be our pot. Now, there are some very big differences between this and a proper pot. A proper pot is much thicker, and it actually has cavities built into the bottom of the pot. And the reason for that is so it can maintain a thermal temperature over a longer period of time and be more consistent. This is going to fluctuate in temperatures a lot more. Also, your typical pot, I think, is made of copper, and this one is clearly not. However, I bought this thing for like $13 versus the $250 to $300 for a proper pot. So this is what we're going with. We do have a retention system. Now, there are different ways you can go about doing this. What I did was I bought some threaded rod from a hardware store. I put some lock nuts on the bottom, and then I took an old AMD mounting bracket, back mounting bracket, and drilled it out to accept the threaded rod. And then what I am going to be using for the top is I got this from an old AIO liquid cooler, which will sit on top of the cup. It actually sits on there pretty well, right like that. So these are the things I'm going to be using. However, if you're on an even tighter budget, you could theoretically just take some pieces of wood and drill and cut holes that would be necessary for your mounting system. A couple other things you're gonna need. I bought this insulation phone off of Amazon. It was pretty cheap. And you're gonna want, you're also gonna want shop towels. Now you can use paper towels, but shop towels do a better job of wicking away condensation. So you want to set this in various spots on your motherboard to prevent that condensation from building up on your motherboard and causing a short. Another thing I bought that you may or may not need is I went and bought some really nice Sub-Zero overclocking thermal paste from Thermal Grizzly. Now you may not need this for dry ice because from what I understand, it won't get cold enough for regular thermal paste to crack. However, if you are using liquid nitrogen, you do need to invest in good thermal paste. I just decided to use this as a precaution. So the first thing I'm gonna do is I'm actually going to wrap this, my beautiful cup in insulation. So actually, from what I understand, this is gonna be a bit of a interesting scenario. I'm gonna wrap my cup in insulation and shop towels to help it wick away any condensation. So we'll do our first layer in just shop towels. By the way, I do need to stress, I don't know what I'm doing. I've never done this before. I wanted to do it for the first time on camera so you guys can see whether or not I succeed or fail. So you guys could probably just take votes in the comments right now as to whether or not I will succeed or fail, because this is about as janky as it gets. All right, so we're about to get started. I'm very nervous. I've never done this before. We have to pour the acetone into the cup so that the dry ice has something to melt into. So we're going to, oh gosh, I just made a huge mess. That's not good. That's really not good. I'm an idiot. This isn't an issue. Oh no. And here we have a cooler of dry ice that we are going to put into the pot. This could go. All right, let's try booting up. Is it? Okay, it's trying to post. We're booting into Windows. Oh my gosh, it's booting. Okay, that's crazy. I'm wondering what our temperatures are. Again, I forgot to hook up the temperature probe, and so we have no idea what it's running at. I'm wondering what Windows thinks our temperature is. So it's reading 0 degrees Celsius. So it's not gonna read the proper temperature. So we don't know what we're running at, but all right, let's try to start cranking up the voltage on this bad boy. So we're gonna go to 1.5 volts. So we're gonna try to go to 24.5, which will get us 4.9 gigahertz. I think I need more dry ice. That went really fast. 0 degrees Celsius still. So the nice thing about AMD CPUs on the FX platform is you rarely run into cold bug issues, which is really nice because that's something that's a big problem on Intel systems. If you get too cold, it will fail to boot. AMD systems At least the FX platform doesn't typically have that problem, but on dry ice, even on Intel, you shouldn't run into that situation. So we're going to hit run on Cinebench R15 at 4.9 gigahertz. Oh, you can hear it boiling. We're gonna put some more dry ice in there. So this is kind of working. Like, we are definitely over 0 degrees Celsius, but we are making it through the Cinebench run, and we are at 1.5 volts when before we were at 1.4 volts. Let's see if we can make it through a Cinebench run. All right, 744, that's not really an improvement. So we're gonna save that, but we're gonna keep going. All right, let's see if we can get 5 gigahertz. This shouldn't be an issue. All right, we're at 0 degrees Celsius, and I'm actually gonna skip doing Cinebench runs for a while till we hit instability because I don't wanna go through all of our dry ice. So we're at 1.5 volts. We're just gonna keep going till we hit instability. So if you ever watch my live stream overclocking that I do, this is basically how it goes. We just hit brick walls a lot sooner. So 25.5, oops, 25.5. All right. Save changes and reset. So this should be 5.1 gigahertz. So this is actually kind of working. Like, not brilliantly, because when we run Cinebench, we are exceeding the 0 degrees Celsius, which means I think either the pod is either not capable of retaining the heat or we just have a bad mounting pressure. But we're just gonna keep going. I like to verify with CPU-Z that we are at the frequency we want to be at. We're sitting here at 5.1 gigahertz. Perfect. Let's just keep going. It's a nice big chunk. Still reading 0 degrees Celsius. Right there. In CPU-Z, you can see 5.2 gigahertz. It's the fastest I've ever gone on a CPU. It's pretty cool. And you can hear once we start booting back up, the heat of the CPU is what causes the bubbling in the pot, not the contact of the acetone with the dry ice. So the combination of the three is what's causing it to heat up or to bubble. So that's kind of what's going on here. We are getting a little bit of condensation on this metal piece here, you can see. A little bit of moisture, but that's not much. And we're running at 5.3 gigahertz. How about we set a goal here? Once we reach 6 gigahertz, we run a Cinebench run. But we're at 1.5 volts and we're at 5.3 gigahertz. And this goes to show you that temperature does have a big effect on stability. The lower the temperature on these CPUs, especially, it seems to be that the better stability you're gonna have. Another thing that I have heard about these FX CPUs is you reach a multiplier limit. Eventually, it won't go above a certain multiplier, and I think that's like 32 or something, in which case you have to start increasing your base frequency. We're gonna find out if we're gonna reach that. That would be really cool if we reach that limit. So there's still dry ice in there, so it's actually doing just fine, probably because we aren't running Cinebench and burning it up. All right, so we've run into a bit of a problem here. We apparently put too much voltage in and it's not liking that. We got up to 1.65 volts and the system is not liking that. And it looks like we might be running out of dry ice. But, oh yeah, we're running into a postcode error. We may have applied too much voltage. We got to 5.7 gigahertz. And when we tried to push it to 5.8, we ran into a hard wall. Oh gosh, and here it's not letting me into the BIOS. Oh, there it did. Okay, sweet. All right, let's lower the voltage. It doesn't like the 1.65 volts, so let's do 1.625. Nope, whoa, I mistyped that. 1.625. And I think adding the dry ice helped us just now get into the BIOS, which just goes to show you how low temperatures will help your stability. Add some dry ice. We're gonna go back to, what were we at? 2.8 or 28 multiplier. So we're gonna do that and try to run Cinebench. And that's when you guys will see this thing boil a lot because Cinebench will be very hard on the CPU. So more dry ice. Also, just to show you guys how much condensation we're getting, you can see the handle that was on the cup is frozen over. Like there's actual ice on it, which is kind of cool. So we're booting into Windows at, what is it, 5.7 gigahertz did we say? I don't remember. So right now it's saying 0 degrees Celsius, which is expected, but I expect that to go up a lot once we start running Cinebench. I don't expect it to stay that low. So in fact, we might burn through our dry ice that's in the pot doing that, which means I'm gonna just add some really quick. We're gonna open Cinebench. This is the moment of truth. This could just crash. Like there's a really good chance it's just gonna crash. And this is where you're gonna see this boil a lot. Oh, we crashed. We crashed hard. So let's drop the multiplier by 1/2 and see if we can get through a Cinebench run. So we had to drop the multiplier at 5.6 gigahertz. I think we kind of hit some instability, it crashed. So we're going to try running at 5.5 gigahertz. Hopefully it makes it through. One thing I've noticed is the VRM is getting quite hot, and I'm not sure how competitive overclockers cool their VRMs. I don't know if they have fans that blow on them, but we're definitely, that might be one of our problems is the VRM are overheating. But right now, we're up to 23 degrees Celsius running Cinebench. And it's reading 1.59 volts. So, oh, we crashed. Dang it. We gotta drop the multiplier again. All right, we had to drop our multiplier yet again because we crashed in Cinebench. I think we'll make it through this time. We're only running at 5.4 gigahertz, although I really don't think the multiplier is our problem here. I think our VRM might be overheating. We might not be cool enough once we start running Cinebench, but we're gonna try to get through a run here, see what we can get. I just dumped some dry ice in there, so hopefully, actually I'm gonna grab some more. We're also running very low on dry ice. I could do this all day though. This is like so much fun to me. And our temperature is getting up to 19 degrees Celsius. Again, the pot's not designed to do this. This is just a cup. So I think considering that, we're doing pretty well. Definitely a legitimate pot would be getting us better temperatures. But let's see what we can get in Cinebench. All right, we got a score of 816, which our previous best was 744. So we jumped, what, 52 points, something like that, which isn't the best, but that's what we got. So what did we discover here today? It apparently is easier to get into subzero overclocking. However, there are some problems with this setup. The cup doesn't retain enough heat in order to maintain that cold temperature for the CPU. I'm guessing that's our problem, why we're getting above 0 degrees Celsius during our runs. Also, I think our VRMs are overheating considerably, and that might be why we're having instability on our overclocks. However, in theory, this all works, and you can get into competitive overclocking, or at least subzero overclocking, for a much lower price than buying a pot. Like, this whole setup, all the equipment I used to do this cost me roughly $50. That's including the threaded rod, the cup, the shop towels, all the various things that I needed. So the thermal paste was a bit more expensive, but again, you can probably get away with regular thermal paste in this situation, not for LN2 overclocking, but for dry ice. I think you can get away with regular thermal paste. Maybe we should test that in a future video. Let me know in the comments if that's something you want me to test out. But yeah, we are currently running at 0 degrees Celsius again when we're not running a load on the CPU. So we're definitely capable of running sub-ambient temperatures in this setup for like $50, guys. That's so cheap. If you want to get into competitive overclocking, get a decent AM3 Plus motherboard or LGA 775 motherboard. And those CPUs are so cheap right now on eBay. You can pick up just about any CPU for $10 to $15. And it's a lot of fun to play with. You can also go with the AM3 socket, overclock the Phenom series or the Athlon series. That would be a way to go. Definitely take precautions, but this went way better than I expected. I expected this to just fail, and it didn't. So, I don't know, what else do you want me to say? In conclusion, yes, you can get into subzero overclocking on a budget. You don't have to throw a bunch of money at an expensive pot. Yes, it will work better than this. However, this does work. As always, thanks for watching. Don't forget to like and subscribe, follow us on our social media platforms, check out our Discord and our website so you can pick yourself up some tech-tested merch. And get you into some real overclocking, man. I'm gonna add more dry ice.